Precision etiquette.
A refrigeration system that utilizes 2 or 3 stages of low-temperature refrigeration A uses flowing water to provide refrigeration. B is called a cascade refrigeration system. C provides medium-temperature refrigeration. D provides high-temperature refrigeration.
B is called a cascade refrigeration system.
Systems with operating temperatures down to about -160 degrees Fahrenheit, using the compression cycle may use a system called cascade refrigeration. Cascade refrigeration uses 2 or 3 stages of refrigeration depending on how low the lower temperature range may need to be.
When leak testing a refrigeration system using a high-pressure nitrogen tank, the technician should always A. Leak test through the low side only. B. Leak test through the high side only. C. Use a pressure regulator and safety relief valve at the nitrogen tank. D. Never allow refrigerant to be mixed with the nitrogen.
C. Tank. Use a pressure regulator and safety relief valve at the nitrogen. UA HTM 4.1.
Nitrogen cylinders are shipped at 2,500 sig, and must have its pressure regulated before it can be used. The pressure in the tank is too great for a refrigeration system to withstand, causing the weak point of the system to burst. The pressure regulator is set to prevent this dangerous situation from occurring. A relief valve is also present to prevent tank pressure from reaching too high a level to cause tank, valve, or regulator damage.
The maximum pressure that can be applied to a refrigeration system when pressure testing is A. 50 sig. B. 75 sig. C. Determined by the system's rated nameplate test pressures. D. Determined by the technician.
C. Determined by the system's rated nameplate test pressures.
A refrigeration system will have a design pressure rating for the high and the low side of the system. Therefore, when pressure testing a system, the technician should not exceed the lower of the 2 ratings.
The safest way to charge refrigerant into a system that is running is with a vapor into the high side while under a vacuum. B. Liquid into the high side while under a vacuum. C. Vapor into the low side. D. Liquid into the low side.
C. Vapor into the low side.
Although slower, refrigerant should always be charged into the system in a vapor unless it is a blend, and in that case it must be charged into the system in liquid form using some type of liquid expander to ensure that the refrigerant is being fully vaporized.
When heating a refrigerant cylinder, the technician should never use ABCD warm water, an electric heat blanket, any type of open flame, none of the above.
C. Any type of open flame.
It is never expectable to use an open flame to heat a refrigerant cylinder.
Refrigeration systems must be fully evacuated before charging with refrigerant A to D. Pressurize the system for the expansion of refrigerant. B. To draw oil from the compressor during the dehydration process. C. To increase the rate of refrigerant flow through the expansion valve. D. To remove air and moisture from the system.
D. To remove air and moisture from the system.
All non-condensables must be removed from a refrigeration system before charging the system with refrigerant. Failure to do so will result in poor system operation and shortened system life.
65. A vacuum pump will lose its ability to draw a deep vacuum over time because the capability the oil becomes full of moisture and acids, which will decrease the of the vacuum pump. Refrigerant pressure causes a breakdown of the vacuum. The pump oil. C. The vacuum in the pump causes the oil to become thinner, which will cause excessive wear. D. The high speed of the vacuum pump will cause a breakdown of vacuum pump oil.
A. The capability of the vacuum pump. The oil becomes full of moisture and acids, which will decrease. UA HTM 8.18.15.
There is no way to completely eliminate contaminants from getting into the vacuum pump oil, but changing oil regularly
A refrigerant service valve must be placed in the A mid position in order for the technician to access the system. B back seated position in order for the technician to access the system. C system front seated position in order for the technician to access the D. All of the above.
A. Mid position in order, UA, HTM 25.41. A. Mid position in order for the technician to access the system.
In order for the service technician to gain access to a refrigeration system, using a three-way valve, the valve must be placed in the mid-seated position. Before the technician removes the gauge set, the valve must be moved to its back-seated position.
When using a micron gauge to measure vacuum, the system should be evacuated to a level of to ensure that non-condensables and moisture have been adequately removed. A 15,000 microns, B 10,000 microns, C 500 microns, D 5,000 microns.
C. 500 microns.
Pulling a vacuum to a level of 500 microns will ensure that all non-condensable have been removed from the system. This will ensure that the system will not operate at a high head pressure or to be prone to acid formation.